Pick up a rock in your backyard. It feels ordinary, dead, silent, but some of its atoms may be older than every language, every city, every human bone ever buried beneath the ground. Now imagine something older, not a fossil, not a meteorite, a piece of ice and dust that may have formed before Earth existed, before the sun existed, before the solar system was even a place. In the summer of 2025, one of those objects entered our sky. It was called 3I/Atlas, a 2.6-kilometer ball of ancient ice, moving faster than any comet ever seen. It came from beyond the solar system. It passed through the planets. It erupted in sunlight. It carried chemistry from a star system that may no longer exist. And then it began leaving again. Forever. This is not a story about aliens. It is the story of the third confirmed interstellar visitor in human history, and the first one that arrived when humanity was almost ready. Shortly before midnight on July 1st, 2025, a telescope in the Rio Hurtado Valley of Chile was watching for danger. The Atlas telescope scans the sky for things that move, asteroids, comets, fragments of rock that might one day cross Earth's path. Because the universe does not need to hate us to kill us. It only needs geometry. That night, against the crowded star fields near the center of the Milky Way, Atlas caught something faint. A small moving smudge, almost nothing. But within hours, observatories around the world began turning toward it. By the next day, one number changed everything. 6.14. That was the eccentricity of its orbit. In orbital mechanics, eccentricity is a verdict. 0 is a circle. Less than 1 is an ellipse. The sun owns you. At exactly 1, you are barely escaping. Above 1, you are on a hyperbola. You are not coming back. 3I/Atlas had an eccentricity of 6.14. No planet here could have created that path. Jupiter could not have done it. Saturn could not have done it. The sun could not keep it. It did not belong to us. It came from the stars. On July 2nd, 2025, the Minor Planet Center named it 3I/Atlas, the third confirmed interstellar object. Oumuamua had already passed the sun when we found it. Borisov looked more familiar, a real comet with a tail. But 3I/Atlas was discovered almost 4 months before perihelion. For an object this fast, that was a gift. A sample from another star system had entered ours. And for the first time, we saw it coming. Everything that orbits the sun is falling. An orbit is not an object resisting gravity. An orbit is gravity winning forever. Most objects born inside our solar system follow ellipses. They dive inward, swing around the sun, climb back out, and return again. They are distant, they are ancient, but they are ours. 3I/Atlas was not. Imagine a roller coaster. 3I/Atlas was moving so fast that it flew off the top of the loop. It was never going to complete the circuit. It came from the direction of Sagittarius, near the center of the Milky Way. But that is only the last direction we saw it coming from. For hundreds of millions, maybe billions, of years, this object had crossed darkness so empty that our words for loneliness are too small. It was never a threat, just a visitor moving through. Around the year 2189, it will reach the inner Oort cloud. Thousands of years after that, it will slip beyond the sun's influence, and then it will continue forever. You cannot pick up 3I/Atlas. You cannot land on it. You cannot drill into it. It is moving too fast. It is too far away. And it is never coming back. So how do you date a comet you can never touch? You use the galaxy itself. Over billions of years, the Milky Way stirs its stars. Older star populations become more dynamically disturbed. 3I/Atlas had an unusually high vertical velocity, suggesting it came not from the thin disk, where our sun lives, but from the thick disk. The thick disk is older, rougher, a fossil population of the galaxy. The result was astonishing, not definitely, not with certainty, but possibly, because 12 billion years ago, Earth did not exist. The sun did not exist. There were no oceans, no continents, no moon in the sky. If 3I/Atlas formed then, it is a preserved fragment from a younger universe. Its chemistry may support that. JWST found unusual isotopic ratios in the comet's gases. The carbon-12 to carbon-13 ratio appeared much higher than in comets from our own solar system. That matters because the galaxy is like a soup. Everything heavier than hydrogen and helium had to be cooked inside stars. So finding a comet with relatively little carbon-13 is like finding a bowl of soup frozen before most of the seasoning was added. It points backward, deep backward. The deuterium to hydrogen ratio was also more than 10 times higher than in typical solar system comets, the signature of extremely cold pre-stellar clouds. Cold like a place where chemistry slows to a whisper. Now imagine the parent system. The comet is ejected into interstellar space, and then time begins, not human time, galactic time. While Earth was still only a future possibility, this comet may already have been drifting. While the Sun was still unborn gas, this comet may already have been frozen. While dinosaurs evolved, ruled and died, it was still moving. While humans learned fire and invented telescopes, it was still coming. A letter from a place that may no longer have a sender. Because if 3I/Atlas is truly that old, its parent star may be dead. Its planets may be burned, its star may be a corpse, its sky is gone, and yet this fragment survived. A postcard from a dead star system. A comet is not just a dirty snowball, it is a chemical vault, a frozen archive, a body that stores molecules in ice until a star gets close enough to tear them out. When sunlight hits a comet, ice turns into gas, dust lifts away, a coma forms, a vast cloud around a tiny nucleus, and that cloud can be red, not touched. Red. Point a telescope at the gas, split its light into a rainbow. Look for the missing colors. Every molecule absorbs light in its own pattern. A barcode, a fingerprint. That is how we know what is inside a comet from hundreds of millions of kilometers away. And 3I/Atlas had a bizarre fingerprint. Its coma contained about 8 times more carbon dioxide than water. For a normal comet from our solar system, water usually dominates. But here, carbon dioxide was overwhelming. Radiation baked, hardened, ancient, a skin cooked by the galaxy. Then the sun began peeling that skin away. Before perihelion, methane was not clearly detected. After perihelion, methane appeared. That matters because methane is extremely volatile. If it appeared only after the comet passed the sun, it may have been buried under a crust for billions of years. The comet was releasing ancient chemistry, methanol, formaldehyde, hydrogen cyanide, carbonyl sulfide, methane, and water ice grains. These are not proof of life, but they do mean complex organic chemistry can survive a journey between stars. And then there was the nickel. The Very Large Telescope detected atomic nickel in the coma, but not the usual iron alongside it. Every comet we knew before was local. 3I/Atlas is from another kitchen entirely. A different star, a different disk, possibly a different era of the Milky Way. The speed was strange, the age was staggering, the chemistry was unusual. And when you put those together, you can understand why some scientists asked a more provocative question. Not because the answer is likely, but because the object was too interesting to ignore. Avi Loeb, a Harvard astrophysicist, has argued that some interstellar objects should be examined not only as natural bodies, but as potential technological artifacts. That is not the mainstream view. The mainstream view is clear. 3I/Atlas looks like a comet. It behaves like a comet. It outgasses like a comet. It brightens like a comet. It has a coma, dust, and volatile chemistry. It is almost certainly a comet. But almost certainly is not the same as boring. Loeb and a small group of researchers catalogued anomalies they believe deserve investigation. The retrograde orbit, the sunward anti-tail, the nickel without iron, possible jets, and the geometry of perihelion. This is the dangerous part of the story. The human brain loves patterns. It sees messages in noise, and space is the largest shadow we have. So we have to be careful. The right response to anomaly is not belief, it is measurement. Many of these features may have simpler natural explanations. Some may be exactly what you expect from a new kind of comet. A new kind of comet. Not artificial, not impossible, new. Radio telescopes looked for artificial signals. They found no artificial signal. Nothing. Meerkat detected hydroxyl, a natural byproduct of water breaking apart. Not a beacon, not a message, a comet. And that should not disappoint us. The need for aliens to make this object interesting is a failure of imagination. A comet possibly older than the Sun does not become less astonishing because it is natural. It becomes more astonishing because nature made it. No intention, no message, no sender, and still somehow a letter. For most of human history, the solar system felt isolated. The planets belonged to the Sun. The comets came from the Sun's outskirts. Other stars were lights, beautiful, distant, unreachable. 3 interstellar objects changed that. Oumuamua was small, fast, and strange. Borisov looked like a recognizable comet. Then came 3 I/Atlas, bigger, faster, older, chemically stranger. 3 objects, 3 completely different stories. That is barely a sample size, but already it tells us something unsettling. The galaxy is not sending us copies, it is sending variety. And we have only just begun looking. The Vera C. Rubin Observatory in Chile is changing the rules. Its 3,200 megapixel camera can scan the southern sky every few nights. Within a decade, we may go from 3 known interstellar visitors to dozens. But 3 I/Atlas also exposed a weakness. We could not catch it. So 3 I/Atlas passed through our system like a sealed museum burning at the edges. We could photograph the windows. We could analyze the smoke. But we could not go inside. Still, Hubble and JWST studied it. JWST confirmed it was spraying roughly 2 tons of water per second into space. It became the most studied interstellar object in history. We did not catch it, but we looked, and the next one may not escape untouched. 3 I/Atlas was not just a comet, it was a rehearsal, a warning that the road between stars is not empty. Our solar system is not a quiet cul-de-sac. It is part of a highway. We are only now installing the cameras. 3 I/Atlas will not return. By late 2026, it will fade beyond the reach of most telescopes. By 2189, it will reach the inner Oort cloud. Thousands of years after that, it will slip beyond the Sun's gravitational influence. And then it will continue. It will drift for billions of years, just as it may already have drifted for billions of years to reach us. That is the hardest part to feel, not the speed, not the size, the time. Human history is too small to hold it, and yet, for a few months, we saw it. A piece of another system crossed ours. Sunlight touched ice that may have been sealed since before Earth formed. Molecules from a dead star's planetary disk escaped into our sky, and we read what we could. But enough to know that the universe is not only vast, it is connected. Material moves between stars. Chemistry survives the dark. Ancient things arrive without warning. And sometimes, if we are lucky, we are awake when they pass. 3 I/Atlas will never slow down. It will never turn around. It will never come back. But for a moment, the solar system received a letter from deep time. We opened it. We read a few lines. And now it is gone. If you enjoyed this video, consider subscribing, and I'll see you next time.